Hi everyone, in this video we're going to be doing A-level further maths 9231 paper 34 for the mechanics major in 2025. This paper is 1 hour 30 minutes long, so we'll try to finish within the time limit. So without further ado, let's get started. Okay, so for the first question, we're told that a light spring, so that means you can compress it or extend it and you'll still have elastic potential energy of natural length A and modulus of elasticity 20 mg is placed so that it stands vertically on a horizontal plane. And we're also told that the lower end of the spring is fixed to the plane. And then we're also told that particle of mass m is attached to the upper end of the spring. Okay, and then we're told the particle is pushed vertically downwards until the length of the spring is 3 over 5a. The system is then released from rest. So they pushed it down until it was compressed because the length of the spring is less than the natural length, and then they released it. So using all this, you have to find the maximum extension of the spring in the subsequent motion. Okay, so first of all, let's draw a diagram with the spring. So initially it was compressed. Okay, so this is the particle with mass m, and the length of this spring initially is 3 over 5a. Okay, so now they want us to find the maximum extension. So let's use some common sense here, okay? So when will you have maximum extension? When you maximize your EPE and you minimize all the other forms of energy. But you have to know that if you want to have a maximum extension, there's no way you can minimize GPE. You can only minimize KE. So when the spring has maximum extension, there is only going to be EPE and GPE. Okay, so we're gonna let the length, like in the final position, let me first. Okay, so as I was saying, remember the x is this length that moving in. Okay, so now we're ready to start. Okay, so let's find how much energy there is initially. Still quite laggy. Okay, so sorry for the delay. It was lagging a lot. So as I was saying, let's now find the total initial energy. So initially, there's only going to be EPE because we are going to take GPE relative to the initial position. So the GPE at the initial position will obviously be 0. So let's find the EPE. So to find the EPE, you just go to MF19. Under further mechanics, you'll see under elastic strings and springs, you'll see this formula where the subject is E. So this is the formula for the elastic potential energy. So you can see it's lambda x squared over 2L. Okay, so let's write it down. So lambda is the modulus of elasticity, and then x is the extension or compression. So in this case, it's just going to be a minus 3 over 5, a whole thing squared, and then L is the natural length, so 2a. Okay, so let's do it. Let's simplify everything. So this cancels out, this cancels out. So 10 mg a minus 3 over 5a. So you'll get 2 over 5a, so 2 over 5a squared, you will get 4 over 25a squared. So 4a squared over 25a. So we can cancel the a out. So 10 times 4 for 25, that is 8 over 5. So final answer is 8 over 5 mga. This is the initial elastic potential energy. Okay, now let's find the total energy in the final position at maximum extension. So let's find the GPE gained. So that's just mgh, where h is the height moved, and in this case, we are assuming that it moves x meters up, so it's just mgx. Yep, okay. Now we're gonna find the EPE again. So lambda x squared, so lambda is 10 mg x squared. So here you have to be careful. X squared, x is again the new extension. So for that, you need the total length of the spring, which is x plus 3 over 5a, minus the natural length, because we're finding the extension, not the compression. So this is x plus 3 over 5a minus a whole thing squared over 2a. So this cancels out, 5 mga, then you get 5 mg, and then 3 over 5a minus a, you get x minus 2 over 5a whole thing squared over a. So this is our total final energy. Now we're going to use our conservation of energy and equate the total initial energy to the total final energy. So that would be just be 5 mg times x minus 2 over 5 a whole thing squared over a plus mgx equals to 8 over 5 mga. Okay. All right, now let's multiply both sides of the equation by a. So this would give you 5 mg times x minus 2 over 5a whole thing squared plus mgax equals to 8 over 5 mga times a, so just a squared. Okay, now we're going to expand this. So to expand this, just use your a minus b squared. What's lagging again? Equals to a squared plus, sorry, minus 2ab plus b squared. So a squared is just x squared minus 2ab, that's minus 2 times x times 2 over 5a. So you get 4 over 5ax plus minus 2 over 5a whole thing squared, you would get 4 over 25a squared plus mgax equals to 8 over 5 mga squared. Okay, so now we have 5 mg x squared minus 4a x plus 4 over 5 mga squared, yeah, plus mgax equals to 8 over 5 mga squared. Okay, now let's move everything to the left-hand side. So, and group all the like terms together. So we have 5mgx squared minus 4ax plus mgax. Wait. Oh, wait. Oh, sorry. This is supposed to be mgax. Yep, okay. So, yeah, total is 3mgax. And then the mga squared terms, you have 4 over 5 mga squared minus 8 over 5 mga squared. You will have minus 4 over 5 mga squared equals to 0. So now we're going to cancel out the mga, that's a common factor, and we're going to multiply the both sides of the equation by 5 to get 25x squared minus 15a squared minus 4a squared equals to 0. Okay, so now we have a quadratic equation to solve. So to solve this, you can use the quadratic formula, or you can factorize if you can, but my factorization is pretty bad, so I'm just going to use the quadratic formula. So minus b, that's minus 15a, so 15a plus minus square root of b squared, so minus 15a squared, you will get 225a squared minus 4 times a, so 25 times minus 4a squared over 2a, so 2 is, a is 25, so 2 times 25. Okay, now I'm going to just type all this into a calculator. So you would get 15 plus 25a, that's 40a, divided by 2, divided by 25, you get 4 over 5a. Wait a minute. I have a feeling that something's not wrong. Something's wrong in here. Oh, I realized my mistake. Okay. Oh yes. Okay, so sorry everyone. Uh, yeah, so this is supposed to be 20. So this is going to be 10. So this is actually 10 mga. So this is 10, not 5 mga. 10 mga. 10, 10 times, this is twice, right? Yeah, a square. And then this is 8 over 5 mga squared. So you can get 10 mgx squared minus 7 mgax and minus 8 over 5. Wait a minute. 8 over 5 mga squared minus 8 over 5 mga squared. You don't get any term here. So yeah, sorry for this, everyone. Okay. Yeah, so final equation would be 10a squared minus 7ax equals to 0. So yeah, this one you can just factor out your x, get x times 10x minus 7a equals to 0. Then you get x equals to 0, or you get 10x minus 7a equals to 0. And then x, you just get 7 over 10a. So obviously, you have to reject this because if x is equals to 0, then that means like there is no extension, it will just stay compressed. So yeah, this is the only answer we can accept, and we're not done yet because x is just the length which it moved by. So we have to do x plus, okay, so extension. We have to do x plus 3 over 5a minus a. So you get 3 over 10a. So this is our maximum extension and the final answer for this question. Let's head on to the next question. Okay, so for this question, we're told that a particle P of mass m kg moves along a horizontal straight line against a resistive force of magnitude 2 mv cubed newtons, where v meters is the velocity of P at time t seconds. We're also given the initial conditions that when t equals to 0, v equals to 1. So for the first part, we have to find expression for v in terms of t. Okay, so to do this question, let's first write down Newton's second law, F equals to ma. So F is the, what do you call, the resultant force, yeah. And since the only force that we're told is the resistive force, we're gonna put a negative sign over it. So 2mv cubed equals to m, and then a is gonna be dv dt, since we want to find an expression of v in terms of t. And by the way, if it said v in terms of x, instead of using dv dt, we can use a equals to v dv dx. But since it didn't, we're not using this. Okay, now cancel out the m, and you get this differential equation that you have to solve. So to solve this, you move the v terms over to the right-hand side where the dv is, and move the dt over to the left-hand side. So you get dt equals to 1 over minus 2 v cubed dv. So you integrate both of these with respect to dv. So 1 dt, you get t plus c. And then as for the right-hand side, you can take out the 1 over negative 2, you get minus half. The integral of 1 over v cubed, you can write as v to the power of negative 3 dv. Okay, so you get minus half times v to the power of minus 3 plus 1, that's v to the power of negative 2 over the new power, negative 2. Okay, so this is t plus c. All the minus sign cancels out. You would get 1 over 4. V to the power of negative 2, you can write 1 over v squared. Okay, yep. Yeah, now we can substitute our initial conditions. So sub t equals to 0, v equals to 1. So t equals to 0, just get 0 plus c, which is just c, then equals to 1 over 4 v squared. So 1 over 4 1 squared, you would get 1 over 4. Hence, final answer is t plus 1 over 4 v squared. Wait a minute. Okay. But the question asks for an expression for v in terms of t, so we have to make v the subject. And to do that, we're going to make both sides in terms of a single fraction. So we're going to make the left-hand side a single fraction. So make the common denominator 4. You will get 4t plus 1 over 4 equals to 1 over 4 v squared. Now you flip the numerator and denominator, you get 4v squared equals to 4 over 4t plus 1. And then divide by 4, you'll get v squared equals to 1 over 4t plus 1. And then you take square root of both sides, you get v equals to 1 over square root 1 over 4t plus 1. So this is our final answer for this first part of this equation, of this question, sorry. Let's head on to the next question. Okay, so for this second part, to find the displacement of P from its initial position when t equals to 6. So the keyword here is from its initial position. So the displacement of P at its initial position is obviously 0, and P is at its initial position when t equals to 0. So these are the initial conditions that we have to take note of. Okay, so to find the displacement, you just take your velocity equation in terms of t and use the expression v equals to dx dt. So it's the rate of change of displacement, so dx dt equals to 1 over square root 4t plus 1. So again, we have a separable differential equation. So you can move the dt to that side. So you get dx equals to 1 over 4 square root 4t plus 1. You can write 4t plus 1 to the power half, to the to the power to 1 over 2, to the power of 1 over 2 dt. So now we can integrate both of these. So 1 dx, that is just x plus c. And then the integral of this can rewrite as 4t plus 1 to the power of negative half dt. So you get x plus c, that's equals to 4t plus 1 minus half plus 1, you get half over, you divide by the new power, half, and then you again multiply the denominator by the integral of the inner function. So the inner function is 4t plus 1. You differentiate it, you get 4. Okay, so x plus c, it gets square root 4t plus 1. Half times 4, that's just 2. Okay, now we're going to find the c. So again, I'm going to start the initial conditions t equals to 0 and x equals to 0. So 0 plus c, that's just c. And then 4 times 0 plus 1, you get square root 1, which is just 1. So 1 over 2. Hence, x plus half is equals to square root 4t over 2. And hence, x is, okay, you know what? We can just leave it like this and straight away sum t equals to 6. So x plus half, that's equals to 4 times 6, that's 24. So 24 plus 1, 25. Square 25 is 5 over 2. Hence, x is equals to 5 over 2 minus half, which is 4 over 2. So x is just 2 meters. So this is our final answer for part B, as well as the entire question. Let's move on to the next question. Okay, so for this question, we're told that a particle P is projected with a speed u at an angle alpha above the horizontal from a point O on a horizontal plane and moves freely under gravity. So clearly, if you see the word freely under gravity, it means that the particle is undergoing projectile motion. Okay, and then after that, we're told that the horizontal and vertical displacements of P from O at any subsequent time t are denoted by x and y respectively. So x is the horizontal displacement and y is the vertical displacement. Okay, so for the first part, we have to derive this equation of the trajectory of P in this form. So we have to basically derive this equation. Okay, so to do this, let's form equations for x and y. So x is the horizontal displacement, and you have to know that the horizontal component of the speed of the particle never changes because the only force acting on it is its weight, which is acting vertically. There's like no force that is acting horizontally, okay? So the speed will always remain constant. So the speed is just u cosine alpha. And then obviously we have to multiply it by t. So x is equals to ut cosine alpha. Okay. And then as for y, um, for obviously to find the displacement of y, since the weight acts vertically downwards, um, the vertical the particle p will be experiencing constant acceleration vertically. Okay, so we have to use one of the Suvat equations that has s in it as well as t. And so far, this is the only equation. We can use s equals to ut plus half at. So yeah, so u is the initial vertical component of the velocity. So that's just u sine alpha times t. And then the acceleration, we take it to be negative because weight is acting downwards, but then the velocity is moving upwards. So that's why. So minus half, and then a is g t squared. Okay, so the final equation we get is y equals to ut sine alpha minus half gt squared. Okay, so now we're gonna have to solve these equations simultaneously. And the only way we can do is to remove one of these variables. So we can remove t by taking our first equation and making t the subject. So we get t equals to x over u cosine alpha. So this is the first equation. This is our second equation. Now we can sub. So we'll write sub 1 into 2. So you get y equals to u sine alpha times t. So t is x over u cosine alpha minus half g. T is just x over u cosine alpha, whole thing squared. So the u cancels out here, sine alpha with cosine alpha, you get tangent alpha. So y equals to x tangent alpha, and then you get minus half g x squared over u squared cosine alpha squared. Okay, so y equals to x tangent alpha. Multiplying all this together, you get gx squared over 2u squared cosine square alpha. And 1 over cosine square alpha is just secant square alpha. So final equation is y equals to tangent x tangent alpha minus gx squared over 2u squared secant alpha, secant square alpha. And this is the equation that they told us to find, so we can write shown. And yeah, we're done for this part. Let's move on to the next part. Okay, so wait, let me check. Okay, good. All right, so for this part, we're told that u is equals to 20 square root 2 meters per second, and that the particle p passes through the point where x equals to 64 meters and y equals to 8 meters. And for this part, we have to find the possible values of tangent alpha. So for this question, we can just start using this formula that we have derived. So for simplicity's sake, we're going to write down the entire formula here. And to make this simpler, since we are going to find values of tangent alpha, we're going to re-express secant square alpha as, as 1 plus tangent square alpha. So you can see this from the formula list. Okay. Yeah, so right here. Okay. Yeah, so let's sub our u equals to 20 square root 2. X equals to 64 and y equals to 8. So you get 64 tangent alpha minus g we can write as 10. x squared, that's 64 squared. So type into your calculator, you'll get 4096 over 2u squared. So u squared you can write as 20 squared root 2 whole thing squared. So that would be 800 1 plus tangent alpha squared. That's equals to 8. So 64 tangent alpha minus 10 times 496 over 2 times 800. You'll get 128 over 5 times 1 plus tangent squared alpha equals to 8. Okay, now we're going to multiply everything. So minus 128 over 5 minus 128 over 5 tangent alpha squared. That's equals to 8. Okay, so multiply everything with 5. 64 times 5 equals to 320 tangent alpha minus 128 minus 128 tangent alpha, tangent square alpha, it equals to 8 times 5, you get 40. And then now you move everything over to the right hand side. So you get 128 tangent square alpha minus 320 tangent alpha and 40 plus 128, you get plus 168 equals to 0. So now we're going to simplify everything. So let's see if we can divide everything by 16. Oh, okay. So we can only divide everything by 8. So you get 16 tangent square alpha minus 320. We get minus 40 tangent alpha plus 168 divided by 8 plus 21 equals to 0. Okay, now let's try factorizing this equation. So 16 minus 40, 21. You will get 4 tangent alpha minus 7. You'll also get 4 tangent alpha, minus 3 equals to 0. So 4 tangent alpha minus 7 equals to 0, you would get tangent alpha equals to 7 over 4. And then equate the other bracket, so 4 tangent alpha minus 3 equals to 0. We would get tangent alpha equals to 3 over 4. Yeah, so these are our possible values for tangent alpha, 7 over 4, 3 over 4. And these are final answers. So let's head on to the next question. Okay, so for this question, we're told that a hollow cone with a smooth inner surface, so that means anything inside it would not experience any friction, is fixed with its vertex O downwards. Then after that, we're told the semi-vertical angle of the cone is alpha, where tangent alpha is 3 over 4. So using this, we can construct a right angle triangle. So the opposite is 3, like the side opposite the angle alpha is 3, and the side adjacent to it is 4. So using Pythagoras theorem, we can easily figure out this side is 5. This would be helpful in determining what sine alpha and cosine alpha are later on. Okay, so moving on, a light inextensible string has a particle A of mass m attached to one end and a particle B of mass m attached to the other end. So you can see this is A attached to one end and B is attached to the other end. The string passes through a small hole in the cone at O. Yes, so it passes through here. B hangs in equilibrium below O. Okay, so that means the forces here, they're balanced. So this is the only force acting on B, it's weight. So the tension here is also mg. Okay. Okay, so what else? So the particle PA is on the inner surface of the cone at a height h above the level of O, so it's given here, and moves in horizontal circles with constant angular speed omega. So the angular speed of A is omega. Okay, so now we're gonna have to find omega in terms of G and H. All right, so to do this question, um, let's label all the forces acting on A, all right? So first of all, the tension that's acting to the part of the string connected to A is also mg, like because it's one whole string, and from mechanics, we know that the tension in a string must always be the same, like if it's the same string, and then the direction must be opposite at the opposite ends. Yeah, so yep. And then also we also have the weight of A, which is mg, and we also have the normal contact force, which is perpendicular to the surface of the cone. So this is going to be N. Okay, what else? Yep, there's no friction because it says it's a smooth inner surface. Okay. Yeah, these are all the yeah, that's it. Okay. So yeah. Yep, okay. So now we're going to equate the vertical forces, like the vertical component of the forces acting on A, because for circular motion, when a particle is moving in circles, the vertical forces acting on the particle, they must be in equilibrium. So let's take, let's equate the vertical forces. So we have mg, and don't forget we also have the vertical component of tension, okay? Yeah, so the angle here is alpha because the angle here is also alpha. So this is the vertical component will be mg out mg cosine alpha. So plus mg cosine alpha. As for the normal contact force, going to okay, so since this is a right angle and this is 90 minus alpha, this is going to be just alpha. So the vertical component is n sine alpha. So let's write down the final equation. So mg plus mg cosine alpha, that will be equal to the vertical component of the normal contact force, which is n sine alpha. Okay, so all right, what else can we do? Oh, like I said, we can use this triangle to find out what cosine alpha and sine alpha are. So cosine alpha, that is clearly 4 over 5. Sine alpha is 3 over 5. So cosine alpha is 4 over 5 mg plus mg equals to 3 over 5 n. So 4 over 5 plus 1, you would get 9 over 5 mg equals to 3 over 5 n. So we can make n the subject. So 5 cancels out, so you get 9 mg equals 3n. So we get 3 mg. So this is the first equation. Okay, and now, yeah, so now we're gonna find the centripetal force, the horizontal force acting on A. So we obviously have the horizontal component of the tension, which is now mg sine alpha, as well as the normal contact force, which is n cosine alpha. So we're gonna equate the horizontal force, which is also the centripetal force because it acts towards the center of the circle. So mg sine alpha plus n cosine alpha. This would be equal to, so, okay, so since we're given the angular speed, we're going to use F equals MA, and then for A, we'll substitute R equals omega squared. So you get F equals MR omega squared. So there's just going to be MR omega squared. Okay, so again, sine alpha, that is 3 over 5 mg, and then n is just 3 mg. Cosine alpha is 4 over 5, and then m, and then r. R is this length right here. So using basic trig, since we know what the h is, right? Okay, so tangent alpha is opposite, which is r, over the adjacent side, which is h. So r would just be h tangent alpha. So h tangent alpha, they already gave us, that is 3 over 4 omega squared. So we can cancel out the m from both sides of the equation. Yeah, so now we only have g. So just we have to keep the g because the question told us to express in terms of g. So 3 over 5g plus 3 times 4 over 5g, you would get 3g. That is equal to 3 over 4 h omega squared. So now let's make omega squared the formula, the subject of this equation. So multiply 4 over 3, 4 over 3, you will get 4g. This also cancels. So you just get 4g over h. Hence, omega is just square root of 4g over h. So this is our final answer for this question. Yeah, omega equals to square root 4g over h. Let's head on to the next question. Okay, so for this question, we're told that ABCD is a uniform square lamina with side 6A. So this has to be 6A as well as this, as well as this, as well as DC and AB. And we're told points E and F are on DC and AB respectively. Yeah, so DC, yeah, it's all given in the diagram, and such that DE equals to FB equals to H. So DE and FB, they're also the same. Quadrilateral BCF is removed from the square lamina. Yeah, so this is the missing part that they removed. All right, so using this, we have to show that the distance of the center of mass of the resulting lamina AFEB from AD, so from here, we want to find the distance. We'll let it be x bar, is this, and we have to find the corresponding expression for the distance of center of mass from AB. So we have to find this as well. For this, we're gonna let it be y bar, okay? Okay, so to do this, we're gonna find both of them at the same time. So if you're told to find the center of mass of any lamina, first instinct should be to make a table with the shapes that make up the lamina or have been removed from the lamina. There's actually two ways you can approach this. First is to consider the whole square as well as the quadrilateral, but that seems a bit too difficult. So the easier way to do this is to split this up into two shapes. So you have a rectangle DEA. I'm going to let this point be G, so DEAG, and triangle EGF. Okay, so yeah, so we're going to find DEAG, and you have to find their areas as well. And then lastly, you can find the centers of mass. Okay, oh, and my G looks like a 6. Okay, so yeah, G. Okay, so for for center of mass, you should write X, which is like the distance from AD, and center of mass Y, which is the distance from AB. Sorry, not Y bar. Okay. All right. So now we can find the area. So DEAG, the area 6AH, 6AH. Centers of mass. It's just going to be the midpoint. So to find it, you just take this length, which is just half of h. So h2, and then the vertical distance would be this, which is just half of 6a. So that's just 3a. Okay, now we're going to find EFG. So the area of this, since it's a right angled triangle, we can let this be the base, GF. So GF, this is H, so 6A minus H minus H, that's minus 2H. And the height is 6A. So half times base, okay, height times base. Half times 6A is just 3A times 6A minus half. You get 18A squared minus 3AH. Okay, yeah, so this is the area for EFG. So the center of mass for EFG. So you have to find the center of mass. So to find it, this applies to any triangle, okay? You just take the x coordinates. If you want to find the horizontal displacement, take the x coordinates. So G is H, F is 6A minus H, yeah, and then E is H. Yeah, so, and now you add these up all together, H plus 6A minus H plus H over 3. So minus H plus H cancels out. So you just get, 6A plus H over 3. So 6A over 3, that's 2A plus H over 3. So this is the final answer, 2A plus H over 3. And for Y, well, you just have to take the y coordinates. So for G, that is 0. For F is also 0. And for E is 6A. So 6A plus 0 plus 0, you just get 6A over 3. You just get 2A. So this is the center of mass for EFG. Okay, now the final step, there's not much space left, is to take the everything like the area center of mass of the whole lamina as a whole. So I'm just gonna write lamina. So area, you just add these two up. So 6AH plus 18A squared minus 3AH, you get 16A squared plus 3AH. And the center of mass, we'll let it be X bar, and we'll let this be Y bar. Okay? All right. So let's find X bar first. So to do that, we'll take moments. Okay. So you take the moment of the lamina first. So 18A squared plus 3AH times M. So this is the mass, and then times the perpendicular distance equals to, let's take for the rectangle, 6AH times M times H over 2 plus 18A squared minus 3AH times M times 2A plus H over 3. Okay, so the M you can just immediately cancel out. Okay, so 18A squared plus 3AH. Yeah, X bar. So this becomes 3AH, this becomes 1. So 3AH squared plus Okay, so 18a squared times 2a, that is 36a cubed, and 18a squared times h over 3, you will get 6a squared h minus 3ah times 2a, you will get minus 6a squared h. Oh, there's not enough space. I'm just gonna continue here. Oh, it's a minus sign. Minus 3ah times h over 3. 3 cancels out. So you get minus ah squared. Yeah. Okay, let me see. Okay. Wait. Let me see my this one is done. Done. Minus 6a squared. Hmm. But I'm just checking like if my expansion is correct. Oh, oh yeah, this one cancels out. Okay, all right. So yeah, we can now find x bar. Uh, h squared 3h. Okay, this one just be 2. Okay, so 2ah squared plus 36a cubed over 18a squared plus 3ah. Yeah. Okay, sorry everyone. Found another mistake again. So this is supposed to be 6a minus 2h, like the base of the triangle. So let me correct it accordingly. So this is 6ah. Okay, let me see. Yeah, so this is supposed to be 6. Okay, let me just yeah, so this is also supposed to be 6. So the area of this is just 18a squared. Okay. Okay, let me see. Okay, yeah, nothing else. Yeah, I was wondering why my answer was so weird. Then this happened. Okay, I have to erase all this. It'll take quite a while. Okay. Right. Okay, here we go. Okay. So, I'm just gonna take the 18a squared x bar that's equals to uh 18a squared minus 6ah times 2a plus h over 3 plus 6ah times h over 2. So expand everything and simplifying that. So 18a squared times 2a, that is 36a cubed. For 18a squared times h over 3, you get plus 6a squared h, and then minus 6a h times 2a, you get minus 12a squared h, and then minus 6ah times h over 3, you would get minus 2ah squared. And then this one, you just get plus 3ah squared. Oh, just remove the a squared. Yeah, wait, no, don't. Okay, now we'll just collect all the like terms together. So 36a cubed uh, minus 12a square h plus 6a square h, you get minus 6a square h. 3ah squared minus 2ah squared, you get plus a h squared. Okay, yeah, so we can divide both sides by a, so this cancels, this becomes 2. this cancels and this cancels out. So x bar, okay. Okay, you get h squared minus 6ah plus 36a squared over 18. 18a, sorry. Yeah, so this is final answer. Let's write shown, and now we're going to find the corresponding y value. So that is 18a squared y bar equals to um, 2a times 18a squared minus 6ah plus 3a times 6ah, that is 18a squared h. So you get 18a squared y bar, that is 36a cubed minus 12a squared h plus 18a squared h. So the a squared cancels out, so this just becomes a, this is just gone. So y bar will just be 36a minus 12h plus 18h, that is plus 6h over 18. Yeah, okay, yep, this is our final answer. Our second answer for this first part is 36a plus 6h over 18. Okay, let's head on to the next part. Okay, so for this part, we're told that when the lamina AFED suspended from the point D, the edge DA makes an angle theta with the downward vertical, where tangent theta is 7 over 15. So for this part, we have to find in terms of A, the two possible values of H. Okay, so to do this, we're going to like make a little sketch. So this point D, and okay, so it looks something like this. Okay, so this is the point D, and when it's suspended, like the line of action, like of the weight, must pass through this edge and this center of mass. Okay, so DEAF, DEAF. So DA makes an angle theta with the downward vertical. So this is theta, where tangent theta is 7 over 15. Okay, so we know the, sorry, oh yeah, so we know the length of DA, which is 6A. And we also know this length, the distance from the center of mass of this lamina to DA, which was our x bar. So I'm just gonna write x bar, and then as of this, you just take dA, which is 6a minus y bar. So this is y bar. So 6a minus y bar. So our tangent theta is equals to the opposite. So x bar over the adjacent 6a minus y bar. So 7 over 15. Just gonna first do it in terms of x bar and y bar. So let's cross multiply. So 7 times 6a minus y bar, you get 42a minus 7y bar equals to 15x bar. So 42a minus 7 times y bar. So y bar is 36a over 18, that is 2a plus 6h over 18, you would get plus h over 3 equals to 15x bar. So x bar is the result we proved in the earlier part. So h squared minus 6ah plus 36 over 36 a squared, sorry, a squared over 18. Okay, So yeah, so this is 6a. So simplifying, you get 42a minus 14a minus 7 over 3a equals to uh oh gosh, okay, wait, let me okay. You know what? I'll just do it one by one. Still quite kind of bothering me. Okay, we're done. All right. Okay. Yeah. So 5 over 6ah squared minus 5 over 6 times 6ah. So you get minus 5h. Yep. And then 5 over 6, 8 times 36a squared. You get 5 over 6 times 36, which is plus 30a. Yeah. Okay. So now we're just gonna express, we group all the h squared terms together and the h terms. So minus 5h plus 7 over 3h, you would get minus 8 over 3h. Okay, and then 30a plus 14a minus 42a, you would get 2a, okay, close to 0. All right, now let's multiply both sides by 6a. So you get 5h squared minus 8 over 3, 6a, you would get minus 16ah squared plus 12a squared equals to 0. Okay, now we're going to use the quadratic formula. So minus b, that is 16a plus minus b squared. Square six minus 16a squared, you would get 256a squared minus 4a is 15, and c is all my 12a squared over 2 times a, so 2 times 15. Okay, so a would just be 256 minus 4 times 5, 12a squared. So square root 16, you get 4a plus 16a divided by 10, you get 2a. And then h, you would get 16a minus square root 16, 12 divided by 10, you would get 6 over 5a. Yeah, so these are our final answers for this part, as well as the entire question. You see the time. Okay. All right, let's head on to the next question. Okay, so for this question, we are told that two uniform smooth spheres A and B of equal radii have masses 5m and 4m respectively. Sphere A is moving with speed u on a horizontal surface when it collides with sphere B when it is at rest. Immediately before the collision, A's direction of motion makes an angle theta with the line of center. So it's all given in the diagram. And then finally, we're told that the coefficient of restitution between the spheres is E. Okay, so for this part, we have to show that the speed of B after the collision is this much. Okay, so first of all, let's write down the speeds of both of them after the collision. So let's write the horizontal speeds first. So for A, it would be, let's say 7 VA. And then the vertical one, for like a collision, the vertical component always remains unchanged. So it would still be U sine theta. As for B, since it is at rest, there is no vertical component. So it would just be VB for B, okay? Okay, so with that, let's start with first one. Okay, so okay, or okay, you know what? Let's take VA. to be in this direction. So this direction is positive and this direction is negative. So E, we're going to take VB minus VA, so plus VA over the initial speed of A, so that is U cos theta minus 0, because U cos theta is in the positive direction. Okay, so we get EU cosine theta equals to VB plus VA. So this is equation 1. All right, now let's make an equation in terms of 2, like, equal, sorry, we're going to now use the conservation of momentum to form the second equation. So let's take the total initial momentum. So again, consider the horizontal force, the horizontal velocity. So 5 mu cos theta plus 0, since B was at rest, that's equals to 4 mvp, because VB is in the positive direction, minus 5 mva. All right, so cancel out the m. Okay, uh, you would get 4 VB minus 5 VA equals to 5 U cos theta. Okay, now let's divide both sides by 5. You'll get 4 over 5 VB minus VA equals to U cosine theta. So this is the second equation. Okay, so we realize that the first and second equation, they both have VA, and by adding these two equations up, we can eliminate VA, and hence we'll have VB plus 4 over 5 VB equals to EU cosine theta plus U cosine theta. So 5 over 5 plus 4 over 5 will get 9 over 5 VB. You will get E plus 1 U cosine theta. So VB is equals to 5 over 9 U E plus 1 cosine theta. So we can write shown, because this is a result that they want to show us. This would be our final answer for this first part of this question. Let's head on to the next part. Okay, so now they told us that after the collision, the KE of A is equal to the KE of B. So what we were told that tangent theta is 2 over 3, we have to find the value of E. Okay, so to find the KE, we have to find the initial and final speeds of both A and B. So the final speed of A, we're gonna let this be V, okay? So V squared would just be VA squared plus U squared sine squared, okay? So VA squared, okay, we're gonna use the first equation and make VA the subject, so that would be EU cos theta minus VB. So EU cos theta minus VB squared plus U squared sine squared. So let's expand this one. So you get E squared U squared cos squared theta minus 2 VB EU cos theta plus VB squared plus U squared sine squared theta. Okay, so U squared would be, oh yeah, we don't know what U squared is, so I think we just leave it alone. Sine cos squared, okay, let's also leave that alone. VB, we know that, okay, we're just gonna do 2 EU cosine theta, and then VB would just be 5 over 9 U times E plus 1 cos theta, cosine theta, plus VB squared. So that is uh, 25 over 81 u squared, e plus 1 squared cosine square theta, plus u square sine square theta. Yeah, that's a lot of algebraic simplification. So we have to do it, everything. So minus 2u times 5 over 9u, you would get minus 10 over 9u squared. And then e times e plus 1 cosine square theta, plus 25 over 81 u squared, e plus 1 squared cosine square theta, plus u square sine square theta. Okay, I think we can simplify it further. Okay, there's not much space, but so I'm going to make my handwriting smaller. Okay, so this is just going to be e squared plus e. So multiplying this, we'll get e squared, u squared cos squared, uh, minus 10 over 9 e u squared cosine square theta, plus this is going to be e squared plus 2e plus 1. Okay, so 2581 e squared u squared cosine squared plus 50 over 81 e u squared cos squared plus 25 81 u squared cosine square theta plus u squared sine square theta. Okay, now let's group all the like terms together. So the EU squared terms, okay, we have this, yeah, so that is 1 minus 10 over 9 plus 25 over 81. Get 16 over 81 e squared u squared cos squared theta, and then the EU terms, so EU, 50 over 81 minus 10 over 9, you would get minus 40 over 81 EU squared sine squared, cosine squared theta, plus 25 over 81 u squared cosine squared theta, plus u squared sine squared theta. Okay, as for VB, and now let's find VB squared. So VB squared would just be 25 over 81, 5 over 9 squared, uh, u squared cos squared theta, uh, e plus 1 squared. So VB, you would get, this is just e squared plus 2e plus 1. So you get 25 over 81 e squared u squared cosine squared plus 50 over 81 e u squared cosine squared plus 25 over 81 u squared cosine squared theta. Okay, now, oh, that's okay. So half mv squared goes to half mvb squared. So if you see the half m, they will, oh wait, sorry, this is 5. So this is 5m, right? Is it 5? Yep, it's 5 and then it's 4. Okay, so and then the 4. So you have 5v squared. So 5v squared. Oh my. You get 25 over 81. Uh, e squared u cos squared theta plus 50 over 81 eu squared cosine squared theta plus 25 over 81 u squared cosine squared theta plus u squared sine, oh my gosh, sine squared theta equals to 4 times 25 or 81 e squared u squared cosine theta. Oh my gosh, okay, plus 50 over 81 e u squared cosine squared plus 25 over 81 u squared cosine squared. So we can now factor out u squared cosine squared. Okay, so final expression would be 125 over 81 e squared. 50 times 50 over 81. Uh, yeah, plus 250 81 e plus uh then 125 over 81 plus tangent square theta. So 5 times tangent squared theta. So that is 5 times 4 over 9. You will get 20 over 9. Yep, you'll get 20 over 9. Okay. That is equals to 100 over 81. Oh my, e squared. Uh, 200 over 81 e uh, plus 100 over 81. Okay, we would get 25 over 81 e squared plus 50 over 81 e. 125 minus 180. Yeah, 180. Sorry. Uh, plus 180 minus 100, you would get plus 205 over 81 close to 0. So I'm just going to simplify and factorize in one step, okay? So factorizing 25 plus 50, 205. Wait, what? 25 over 81, 50 divided by 81, 205 over 81. Wait, what? Oh no. What did I do? Oh no. Let me see what's the time. Oh no. Let's see. Okay, okay. The mm, see uh tangent square, that is, yeah, 4 over 9. So yeah, 20 over 9. Uh you get 5, 10, uh, wait, what? Okay, wait, I think I might have copied something down wrongly. Okay, okay, sorry everyone. Again, I copied something directly. So this is supposed to be 40 minus, okay? Yep, it's 40. And then this one is yeah, 50 and 25. Okay. Yep. All right. Okay. So this is going to be 200. Okay. 200, and then this will be the same. This will be the same. Yeah, so as you can, wait, what? Wait, how? Wait. Something is not right. Uh, give me a while. 100 e squared. Hmm. Ish. Wait a minute. Let me see if I copied anything else down. Wrongly. You squared any squared terms? I don't think so. Yep, it doesn't seem like it. Okay. Oh, wait. Oh, this one. No, that's e squared. Sorry. Um, this is pretty tough. Okay. Oh, no. Oh. Eh? it's supposed to be 40. Okay. Okay. So it's actually supposed to be plus, wait, let me see, 16. Okay. So there's two errors. So this is supposed to be 60, and this is supposed to be plus 40. Okay. So this is supposed to be 80, and this is supposed to be 200, 125. Let me see if I, okay, all right, okay. Cool. Okay, so yeah, so all right, I'm just gonna cancel this out. So this is gonna be 20 over 81 e squared, and then uh, wait a minute, what what is this? Oh my gosh, wait. Okay, this 40 e. Okay, all right. 200, 200. Oh no. Something is wrong here. The constant terms are right. Something is going on. So the E terms is something is wrong in here. So that's 200. Um, okay, wait. So 16, 25, 5 times tangent squared, you get 4 over 9. So 20 over 9, right? Okay, so this would be. I feel like something is wrong in here. Oh my gosh. Let me. Okay. Okay, so after all this manipulation, you're supposed to end up 4e squared. Uh, for eh, yeah, 4e squared minus 8te plus 41 equals to 0. And you can factorize this, okay? It's 80, 41. Oh, wait. So, okay, sorry. I swapped my sign again. Uh, so this is going to be minus 40. So factorizing this, you'll get 480 minus 41. You will get 2e minus 1 times 2e. Oh my, 2e plus 40. Oh my, sorry. 41 equals to 0. And then 2e minus 1 equals to 0. Then you'll get e equals to half. Yeah, so this is our final answer for this part as well as the entire question. Let's head on to the next and final question. Okay, so now we're told that, okay, a particle P of mass m is attached to one end of a light inextensible string of length A, the other end is attached to a fixed point O. Particle moves in complete vertical circles with center O with the string taut. When the string makes an angle theta with the downward vertical through O, the speed of P is 4 ag. The ratio of the greatest and least tensions within the string during the motion is 11:1. So using all this, you have to find the value of cosine theta. Okay, so to do this question, let's first draw a diagram. Let's draw the vertical circle. Okay, so this is the center O. This is center O, and particle P, it's going to be right here. So one thing you have to take note is that the greatest tension in the string would be when P is directly below O. So this is going to be 11t, and the highest would be when the lowest tension would be when P is at its highest point. Okay, so this is just going to be T. And I'm going to let the speed here be U, and the speed here be V. And then we're also told that when the string makes an angle theta with the downward vertical, the speed is square root 4 ag. Yeah, so these are all the information that we're given. Now we can make an energy equation. So now we're gonna make an equation in terms of the energy change from the bottom here to here. So at the bottom, the speed is half mu squared minus, because we're taking the GPE with respect to this horizontal line, minus mga. This would be equals to half m squared 4ag squared, that's just 4ag minus, so this is a cosine theta, so mga cosine theta. So half mu squared minus mga equals to 2 mga minus mga cosine theta. So half mu squared, you will get 3 mga minus mga cosine theta. So you can cancel out the m and multiply both sides by 2, you'll get 6ga minus 2ga cosine theta. So this is equation 1. Now we're going to do the energy change from here to the top. So we'll take the total energy at the top, half mv squared plus mga. Okay, that would be equal to half m for ag minus mga cosine theta. All right, okay, so half mv squared plus mga, you get 2 mga minus mga cos theta. Half mv squared, you would get mga minus mga cos theta. So the m cancels out, and then you get v squared equals to 2ga minus 2ga cosine theta. So this is our second equation. Now we're going to make equations in terms of the forces acting. So first we'll take the centripetal force acting at the bottom. So there's mg and 11t. So centripetal force would be 11t minus g. Okay. That would just be equals to mu squared over r, which is a. Now multiply both sides by a, you get 11at minus mga equals to mu squared. So this is the third equation. Okay, now we'll take the forces acting at the very top where the speed is v. So we have t as well as mg. So take t plus mg equals to mv squared for a. And we'll have ta plus mga equals to mv squared. So this is the fourth equation. Okay. All right, what should we do? All right, so now we're going to multiply the fourth equation by 11. So we get 11at plus 11mga equals to 11mv squared. So this is the fifth equation. Okay, yep. And then, yeah, now we are going to subtract the fifth equation and the third equation. So we'll have 11at plus 11mga minus 11at plus mga equals to 11mv squared minus mu squared. So the t's cancel out. 11 mga plus mg, you get 12 mga. That is equal to 11 mv squared minus m squared. So the m's cancel out, you get 12 ga equals to 11 v squared minus u squared. Okay, so now we're going to use our second equation. Okay, so 12 ga equals to 11 times v squared, that is 2ga minus 2ga cosine theta. Yeah, and then we're also going to use our other formula for u squared. So 6ga plus 2ga. Yeah, plus 2ga cosine theta. Yep, okay, so now expanding and simplifying, we get 12ga equals to 22ga minus 22ga cosine theta plus 2ga cosine theta minus 6ga. So 22ga minus 6ga, you get 16ga. And then you get minus 22ga plus 2ga cos theta, you get minus 20ga cosine theta. And that's equals to 12ga minus 16ga. So minus 16ga plus 12ga, you get minus 4ga. So the negatives cancel out, as well as the ga. You will get cosine theta equals to 4 over 20. And your final answer will be 1 over 5. So this is our final answer for this question. Cosine theta equals to 1 over 5. And we have also come to the end of this question paper. So I hope you found this video helpful. And if you did, please make sure to like and subscribe to this channel and share share this video with anyone else who might find this video helpful. If you have any questions, queries, or doubts, or any future video ideas or any improvements I can make, please feel free to leave them down in the comments below. And I'll see you again next time. Okay, thank you.